1 divided by, what was it? X minus 1 times what was it? X squared plus 4 squared. And if we do something like expand, that usually does it. Sometimes I have to fuss with it a bit. Well, thanks for nothing. You're dead to me, Wolfram Alpha. All right, let's try that again. How about partial fractions? Oh, I think I've missed a parentheses. Maybe. Sorry, I'm having parenthetical problems here. There we go. So once we get through the algebra, we should find our way to 1 over 25x minus 1, and then like this for the other terms. So, you know, you're not alone in the algebra. You can check your work with this, or with a friend, right? Now, did we get? I'm now worried to check. Well, we got the 1/25th, right? I got d was minus 1/5. D was what? The x term looks like oh yeah, minus 1/5. All right, so we're on the right path. But other questions? 28. So you guys see what I'm saying? I mean, there's a right way and a wrong way to use Wolfram Alpha, right? There's a right way and a wrong way to use graphing calculators. If using a graphing calculator has made it so that you are unable to do things like graph basic polynomial functions at this stage in your life, you use them wrongly. And I'm sorry, we can't undo that. But, you know, there's also a right use, which is to kind of explore and supplement the usual pen and paper stuff. This one here, I mean, I'm not a Luddite. I don't eschew the use of technology. We have ax plus a plus bx and c plus dx. So what's the technique that you'd use here? Ax plus b, was it? Cx plus d. Oh, a plus bx, I can't. Oh, and I did tell you that a, b, c, and d are non-zero. So what could you do? Like a plus bx equals to b times what? All right. I mean, there are various approaches. You could do like that, right? And so doing that here, I'm mostly just doing that so you can see it for what it is. BC a, oh, excuse me, what is it? X plus b a over b. And then x plus what? C over d, yeah? Well, d over c, rather. No, c over d. I'll get it eventually. Do the algebra. After I do that, can you see? I mean, then it fits one of our standard patterns, right? So you can do the partial fractions. What would the partial fractions decomposition be here? Something like a, big A, over x plus a over b plus big B over x plus c over d. Now, or another path, guys, you could go looking for this being equal to, let's say, a tilde over ax, a plus bx, plus b tilde over c plus dx. I mean, you could just do it like that. You could try to do the algebra that way just the same. It'll work out either way. Yep. Uh-huh.
And then when he went down with a over x plus a over b plus b over, where's
Well, you know, if I have 13x minus 17 fifths over, you know, x minus 3 times x plus 7, I do a over x minus 3 plus b over x plus 7. I don't care what's up here. It does not matter. And so we should really think about that as like this. So it's just part of the numerator. I mean, whatever happens up there, it'll get accounted for in the mechanics of the how big A and big B are calculated. That's our usual setup. I needed to know that B and D were non-zero to do these divisions, right? And for some reason, you also need to know that AD is not equal to BC. If it was, this problem becomes different. It has a fundamentally different nature when AD is equal to BC. It's a different kind of integral. I think when AD equals to BC, these kind of become the same factor repeated in some sense. Whereas AD not equal to BC makes these distinct linear factors, which means that the partial fractions really does kind of fall into that category. Right? If the factor was repeated, this would not be the setup, would it? I mean, if A plus bx and c plus dx were really the same root, same linear factor repeated, it's already in partial fractions. You know what I mean? If I had, you know, 1 over 2 plus 4x times 4 plus 8x, for example, I just go, well, that's really, you know, four times 8 divided by what, times what? Times x plus 1/2, I think, squared, something like that. If the two terms being multiplied were actually the same factor, it would be a different pattern. Putting AD not equal to BC forbids that from happening. Other questions? What's that? 30? That was yours? Ah, there you go. So, yeah, putting the minus there throws a monkey wrench in your plans, yeah? So you got 11 minus x squared minus 4x, right? So if this is stumping you, something you could do, factor out a minus 1. Factor out a minus 1, then this becomes x squared plus 4x minus 11. At which point, you will no longer be stumped, right? Because now you know how to complete the square and you can go from there. This is what? X plus 2 quantity squared. What is that? Minus 4 minus 11. So I actually have 15 minus x plus 2 quantity squared. This bit of algebra for number 30 will help you out, right? Then what substitution would you make given that bit of algebra? Is this a hyperbolic? Is this a trig? I can't remember. I mean, I'd try trig. I usually try trig. It's not pleasant, but I think we want x plus 2 equal to the square root of 15 something. What is that something? Ah, okay, sine theta. Yeah, that's right. That's right. Is that right? Yeah, that's right. Because 1 minus sine squared gives me cosine squared. Yeah. That should allow you to do that one. Other questions? It was about that part of it, right? That was what you guys were stuck on? Am I wrong? Or you get this far? I mean, okay. I think I probably meant to put a 12 here. But it's good for it not to always work out pretty. I mean, sometimes the square root gets involved, right? But if I'd put a 12 here, then this would have worked out to 4. In some sense, that would have been kind of like, you know, less cluttered. So there's a talk Thursday that I really want to go to during this class period. What should I do about that? Thursday, yeah. So what I'm thinking is I will give you guys the math battle tomorrow. But then it's an in-class group exercise. You'll break up into teams and work on essentially a pretest. So it's going to have like it covers the gamut of what this class is about. The only thing that concerns me is then it doesn't really give you a good opportunity to ask questions about the homework tomorrow, which you might want to ask me about tomorrow. I don't know. But what I'd like to do is give the math battle tomorrow, not collect it tomorrow, just give it to you tomorrow. You'll have till the end of class Thursday to turn it in, all right? And then I come at the end of class Thursday to pick them up. But at the start of class, I want to go to this talk. The engineering dean has some guest speaker talking about some creation model or something. I'm curious. You've seen I don't know if you've seen it or not. It's like, if you're interested in going to this talk, I'll try to make an announcement. I don't know if some of you are interested or not, but it's somewhat technical and interesting. And that kind of thing rarely happens here. So what I'm telling you is you'll have 2 days to work on the math battle, which is better. And you just turn it in at the end of Thursday. And you'll see what it is tomorrow. So. Oh, thanks, guys.